It is acids and bases, but as you've figured out, we end up by default talking a lot more about acids. We will talk about bases, but you're going to see pretty soon how they're inextricably linked. And again, the goal for today is that by the end of the day, you know major classifications of acids, how to name them, and you can talk somewhat intelligently about the 5 major important acids. Okay, so common characteristics of acid. There are 5 things that all substances that we call acids have in common. This does not constitute a definition of acids. There are 3 different ways to define acids. We're going to go through all of them. These are just common characteristics of substances that we call acids. So, if we have acid-base indicator paper, that is, how many of you have ever used pH paper? Okay, pH paper often used in pools and hot tubs and maybe in a science class. Acid-base indicator is different than pH paper. So pH paper actually gives you a different color for every level of pH from 0 through 14. Acid-base indicator is a 2-color yes or no proposition. Okay? Acid-base indicator will turn red for acids, blue for bases, I believe. I might have that reversed, but anyway. It is just a yes-no. So acids will change the color of acid-base indicator. Aqueous solutions of acids have a sour taste, and you saw that in the video. He drank what? Vinegar. And probably most of you, if you've had fair fries, have drunk some vinegar out of the bottom of the cup, or you've had something with lemon juice in it, or you've had lemon juice on something. Those are an aqueous solution of an acid, and they have a sour taste. Many acids are corrosive, and so that's one thing everybody thinks, well, if it's an acid, it's corrosive. Yeah, many acids are. There are some weak acids, and you can have a dilute solution of a weak acid that's not going to be terribly corrosive. Certainly lemon juice will not burn through your skin, but it doesn't feel real good in the cut. Same for vinegar. A lot of acids will react with metals to release hydrogen gas. You did a lab in here where you took a strip of magnesium metal. What acid did you combine with that magnesium metal? Remember this? You produced little gas bubbles in the tube upside down. We layered the acid. What was it? Hydrochloric acid. And when you mix the hydrochloric acid, the HCl plus, was it zinc or magnesium we used? Maybe it was zinc. We got a zinc chloride and we got hydrogen gas. Okay? So we got a zinc chloride and a hydrogen gas. That's one of the reactions. Many acids, and you noticed in the video yesterday, they used, I believe it was sulfuric, or it was nitric, to dissolve a penny. So the nitric reacted with the zinc in the penny. Nitric acid would also, it didn't decompose the copper, but it did decompose the zinc. It reacted with it, it didn't decompose it. So a lot of acids will react with metals. When we take an acid and mix it with a base, and I know it's tough because we haven't really defined what these things are yet, we get a salt and we get water. And a salt does not just mean NaCl. A salt is a compound composed of a positive and negative ion, and we'll talk more about those as we go. And a lot of acids, not all, but a lot of them will conduct current, which means they are what kind of substances? Electrolytic, yeah, they're electrolytes. And that's due to the ionization that goes on, where they will decompose, or they will ionize, they will transform into ions in an aqueous solution. Okay, so we're going to talk about acid nomenclature. This is the system of naming for acids. And we're going to start off, I'm going to start off by telling you that there are 2 broad categories of acids. Binary acids are the first broad category that we're talking about. Binary. How many things are in a binary acid? Hold up your fingers, don't yell it out. 2! You guys are so clever. Yeah, binary, 2. So binary acids are made of 2 things, and it's typically hydrogen plus something that is more electronegative. What group on the periodic table is highly electronegative? Pardon? 17 halogens? Do I hear halogens? I think I hear halogens. Okay, so typically this is hydrogen plus a group 17 element. And we talked about a series of things in the last chapter. We talked about hydrogen fluoride and hydrogen bromide and hydrogen chloride. and hydrogen iodide. Guess what? Those molecular substances which are prone to ionization are your binary acids when they are in aqueous solution. So, a lot of these things exist at room temperature as a gas. When they are a gas, when they are a pure compound, when they're not in aqueous solution, we don't call them by their acid names. So, this is hydrogen fluoride, hydrogen bromide, hydrogen chloride, hydrogen iodide. But when we put them into aqueous solution, now we have an acid. So you guys all know the name for HCl in aqueous solution. What is it? Hydrochloric acid. Okay, hydrochloric acid. Can you take a wild, crazy guess at what hydrogen fluoride in aqueous solution is called? Hydrofluoric acid. And hydrogen bromide in aqueous solution is hydrobromic acid. Hydrogen iodide in aqueous solution, hydroiodic acid. It's always the one that wraps people's tongues in a knot. So we've got hydrofluoric acid, hydrobromic acid, hydrochloric acid, and hydroiodic acid. So that reasonable? Seem simple enough? Okay. Okay, so just to formalize that nomenclature, anytime we have a binary acid, it begins with the prefix hydro, and then the root name of the second element with an ic on the end. So remember how we had specific endings for some of our ions, like nitride, nitrate, nitrite? With the binary acids, we have a specific ending, and it's IC. So hydrochloric acid. Okay. We can also have something like H2S. This is hydrosulfuric acid. Okay. So anytime you see just two things like that, and of course this would only be in aqueous solution, just two things like that, and it's an aqueous solution, think binary acid. Hydro something ic. Yes, ma'am? Just saying hydrochloric doesn't say hydrochloric acid. So when I give you a test and I give you a formula and ask you to name the acid, if you write hydrobromic, I'm going to mark it wrong or at least take off half points. It is hydrobromic acid, hydrochloric acid, acetic acid, nitric acid. So, because I'm mean, that's why. Let's talk about the other set of acids, oxy acids. So, all of you being clever critters, what element do you think is present in all oxy acids? No. Oxygen. So, all oxy acids are oxygen containing. And typically we've got hydrogen, we've got oxygen, and we have some other thing. Okay? And very often the oxygen plus some other thing is actually a polyatomic ion. Okay? So think about your nitrate ion. Well, there you've got nitrogen and oxygen. Put that together with a hydrogen, and look at that. You have HNO3. We name these based on the identity. It's common enough for it to be a polyatomic ion that we name them based on the polyatomic ion. So this HNO3 is nitric acid. I'm out of screen there. There is a table in your book in Holt Modern Chemistry on page 455. If you think back to when you were learning all the polyatomic ion names, remember how we've got nitrate, nitrite, sulfate, sulfite. There is a pattern for the various acids. If it's HNO3 versus HNO2, we're not going to go into it right here. We're not going to go into it right now. I will hold you responsible only for the most common, so the HNO3, and we'll talk more about that as we go. HNO3, the things that are made with the 8 ions, so H2SO4, HNO3, those. Okay, the first one we're going to start off with, and if you remember from the movie yesterday, they said you could actually measure the what of a country based on their sulfuric acid production. Yeah, their economic productivity, their industrial capacity, because sulfuric acid is the most commonly produced industrial chemical in the country. Yes, ma'am?
Did you get my worksheet?
I don't know yet.
I don't
So, sulfuric acid is used in a lot of stuff. It's used in paper pulp manufacture. This is what you find in car batteries. It's used in refining processes, and I don't know if it's used, some of the stuff that's going on with the natural gas around here, you're starting to see what's called midstream production. So you have where the gas is pulled out of the ground, where it's fracked out, and then you have the eventual place where it's going to be used. Well, when it comes out of the ground, it's not in a form that it can be used to heat houses or run cars on compressed natural gas or anything else. So they have to do some refining, in essence, though it's not the same as petroleum refining. And I'm not sure if they're using sulfuric acid in that refining process or not. They use a stack that's similar to petroleum refining, but I think it's a little bit different still. So sulfuric acid is very attracted to water. It's a dehydrating agent, and we'll try a dehydration in here soon. Okay, so you've seen what sulfuric acid can do to sugar, and it would do the same thing to your skin. It removes all the water very quickly, generates a lot of heat, and leaves pure carbon behind. And your skin, your whole body is made basically of 6 elements: carbon, hydrogen, oxygen, nitrogen, that's 5, phosphorus, and something else. Not coming to me right now. Potassium? Maybe. Anyway, maybe. If you get sulfuric acid on your skin, it's going to pull out the water, the H2O, and leave behind those other elements and cause really severe burns. So that is why sulfuric is used as a dehydrating agent, because it is so powerfully attracted to water, and it pulls water out of other things so quickly. Since it is the one found in car batteries, sulfuric acid burns are probably one of the more common burns that people outside the chemistry fields would experience. I know someone who had an automotive battery blow up in his face. Not good. Sulfuric acid in both eyes. He can see today only because his father grabbed him by the shirt collar, dragged him into the house, shoved his head under the bathroom faucet, and turned on the cold water full blast and left him there. And he said, I thought I was going to drown. I thought I was going to die. But he saved the vision in both eyes, which is remarkable. He was able to flush enough of it out. Yeah. So it's not anything to mess around with. I mean, it will do very serious damage. His father obviously must have gotten him underwater in, less than 30 seconds? Yeah, seconds. Yeah, that's the kind of time you're working with. So, not something to mess around with. And we'll pop in a picture of dehydration of sugar later. So let's talk about our next acid. Okay, now somebody had said that acids were things that weren't stable. And while that's not true for acids as a rule, it is true for nitric acid. It is true for nitric. Nitric is, in its pure form, it's very unstable. It's not used as often in industry because of that. And if you look at the kind of explosives, what was the common component to all those explosives they talked about? Nitric acid. What was the fertilizer that was so unstable? Ammonium nitrate. So it's that nitrogen piece. TNT, what is TNT?
Explosives.
It's an explosive. TNT stands for trinitrotoluene. So nitrogen compounds tend to be, there are lots of nitrogen compounds that are quite stable. Your DNA, for instance. Very stable. You're not at any risk of exploding imminently because of the DNA in your cells. But there are a lot of nitrogen compounds that are unstable that are explosive. So nitroglycerin and TNT are among them. We typically use more dilute solutions of nitric acid because of that. It doesn't stain you as quickly or as severely as sulfuric, but I can tell you from personal experience that it will still give you a very, very good burn. It is also, I don't know if you noticed, when I opened up our acid cabinet, some of you were probably able to see inside. We keep all our acids in one place. That's per chemical storage regulations. You cannot keep nitric acid next to other acids. It's so reactive, it's so volatile. So we used to keep it on its own in the chem supply. That's really not what you're supposed to do either. So we had to buy a special divider box to go into the acid cabinet to segregate the nitric acid from all the other acids. And that's just, it's that unstable. You have to separate it somehow from other acids for safety reasons. So you've all seen, you know what the wash bottles look like here in the lab. Okay. If you go on to an organic chemistry class, there's your wash bottle. If you, yeah, just so you know what it is. If you go on to an organic chem class, you will find substances that are acid solubles. And you will actually perform extractions where you're using a wash bottle, but the wash bottle is full of acid, not water. Sound a little bit dicey? So I was in organic chem, and we had wash bottles of nitric acid, and I brushed my finger against the tip. Just, you know, as I set it down, brushed my finger up against it. Why I was not wearing gloves is beyond me. I should have been. And by the time I realized, I brushed it against, felt that I'd brushed up against something, and by the time I turned my hand over to look at my pinky finger, it was my pinky finger, I already had a yellow welt in the exact shape of the tip of that wash bottle. So it took, you know, not a second to raise a welt, and of course then I went and flushed it, and it stopped the burning, but I had a good blister, like you would get from a first-degree burn, just in that amount of time from contact with the nitric acid. So not something you want to mess around with. And nitric acid is HNO3. What's the ion? Nitrate ion. We should actually go back. What's the ion in sulfuric? H2SO4. Sulfate ion. Okay. So our next acid is phosphoric. This is one that you probably commonly consume. If you are consuming most pops have phosphoric acid in them. It's also used in animal feed as a source of phosphorus, and it's used in fertilizers for the same reason. So the typical fertilizer nutrients. Anybody ever see a bag of fertilizer? What is it? What are the 3 letters on it? What are they? Do you know? NPK. And you'll see a percentage. So we use nitric acid for the nitrogen. We use phosphoric acid for the phosphorus, because those are 3 essential nutrients for plant growth. Yeah, right. They look at nutrient deficiencies in the soil, and then you get fertilizer to match what you need. And the potassium comes from a variety of other sources. We don't need to involve acids for that. But phosphoric acid is one that you probably commonly consumed, and I would actually challenge you to look at a pop label sometime in the next 24 hours and see if you see phosphoric acid as an ingredient. You typically will. It's in most pops. The exceptions are things like 7-Up, Sprite, Sierra Mist. What acid do you think those have? Citric, because they're lemon lime, and citric acid is the flavor. Citric acid is the flavor we associate with citrus fruits, and those things that are citrus type or citrus style pops have citric acid instead of phosphoric. So phosphoric is also one that is used if anyone knows somebody who has a dairy farm or has ever been to a dairy farm. If you drive up north on 7, you go to Baker's. Dairy farms are subject to milk inspections. So somebody comes through, once every 6 months, and it's the milk inspector, and they look at the cleanliness of your facilities because you're producing a food product. And so you have to clean. Milk goes bad if you have milk on surfaces it's going to spoil. It's a place for bacteria to take hold. So phosphoric acid is used to clean those surfaces, to remove all the proteins, all the milk proteins from those surfaces. Just like they were saying that acids are used in breweries. Okay, CN30. So from phosphoric acid, we will move on to our next common industrial acid. Okay, so hydrochloric acid, HCl, is the one that, of course, you use to digest your food. And it's used in the steel industry. It's used as a cleaning agent. Have any of you heard the term muriatic acid? It was used in the movie Yesterday. My dad used to always talk about muriatic acid. So they use muriatic acid to clean concrete. If you lay down concrete and you get splash onto a surface that you didn't want to have concrete on, the muriatic acid, or hydrochloric acid, will dissolve the little bits of concrete. So it's used for that. It's one of those that you used to find, most homes and farms had a little bit of muriatic acid somewhere in a barn, shed, garage, basement. I don't know how readily available it is either. So this one also mentions used in the activation of oil wells. When they're doing the frack wells around here, the hydraulic fracturing, they talk about the primer fluid. And the literature from the company is kind of insulting because it says things like, the things found in fracking fluid, things like acids, just like lemon juice or vinegar, and, they put it in terms that are meant to reassure the public whether or not they should be reassured. And I'm not saying whether or not they should, but I believe hydrochloric is actually the acid that they're using in the frack fluid. I'm not sure. It's all like trade company secrets they won't tell you. But I know that hydrochloric is used in oil wells, so I'm guessing it's probably something similar. If you recall, so we talk about the fact that it is used for pickling iron and steel. If you think back to those electroacid tanks, they talked about how the acid etched away part of the surface, and that's that pickling idea. So they pickle steel, they clean up the surface, and that tends to reduce corrosion in the long term. Yeah, it's actually used to clean the surface of impurities. It chemically reacts with things that are not the steel. Okay, so vinegar is used. Vinegar is a dilute solution of acetic acid. It's about 5%. We could figure out what molarity that is if we went with the molar mass of acetic acid, but we won't. And it is produced by the fermentation of some plants. Some plants. Sorry about the typo. We'll do that. If you take apple cider and you leave it sitting on the counter without refrigeration, first it gets a little bit fizzy and a little bit bubbly and a little bit alcoholic. And then, after a few more days, it turns into vinegar. That is apple cider vinegar. The bacteria that are present in the cider are producing acetic acid as a byproduct of alcoholic fermentation. So they produce carbon dioxide, that's that bubbly, fizzy part, and they also produce acetic acid. When we say it's got a distinct odor, we could put a pretty dilute solution of acetic acid in this room, and I think any one of you would go, vinegar. It's that distinctive. And people seem to either love it or hate it. It's kind of like licorice. Some of you are going, vinegar, and some of you are going, ugh. So, it's called glacial acetic. It's got a freezing point of 17 degrees Celsius. What does that mean? Well, it's not warm or cold. So 20 is room temperature. 20 to 25 is usual room temperature. I'm not asking you what it means in Fahrenheit. I'm asking you what happens at just below room temperature. Yeah, acetic acid will crystallize. It will turn into a solid. So basically, if you stick pure concentrated acetic acid in the fridge, you may well end up with a solid. So it's got that high a freezing point. No. But this is what you use in. It's what's found in apple cider vinegar, wine vinegar, rice vinegar. All the vinegars that you're going to find are acetic acid. It is used in some manufacturing processes, but not as many. This is more commonly a food additive. And it's used as a fungicide. You can actually, and I use this on my kitchen counters at home, but it is something that kills funguses, that disrupts their growth cycle. If you've got something that's mildewy, wiping it down with vinegar will very often kill the mildew, because you change the pH of the surface, and that fungus is no longer able to survive. So it's a nice non-toxic way to kill off mildews and molds.